morning, ladies and gentlemen. Thank you for joining us at this COMPUTEX Micron keynote speech. This year, COMPUTEX continues to build technology ecosystems with our global partners by going hybrid this year. COMPUTEX activities will include an online exhibition called COMPUTEX Virtual, COMPUTEX CEO Keynotes, COMPUTEX Forum, and InnoVex Forum, and online matchmaking conferences. The development of 5G and AI leads to demand for large volumes of data, and memory chips are becoming increasingly complicated with better performance, less power consumption, and smaller dimensions. In 2017, Micron chose to establish its Center of Excellence for High-Volume DRAM in Taiwan. And 4 years later, Micron took another significant step in its plan to create a Center of Excellence for leading-edge DRAM in Taiwan. This action not only to grow its presence in Taiwan, it is also a trust in the quality of products made in Taiwan. Today, I have the pleasure of introducing this great company and an outstanding technology leader, Mr. Sanjay Mehrotra, President and CEO of Micron. Mr. Mehrotra joined Micron in May 2017 after a long and distinguished career at SanDisk Corporation, where he led the company from a startup in 1988 until its eventual sale in 2016. In addition to being a SanDisk co-founder, Mr. Mehrotra served as its president and CEO from 2011 to 2016, overseeing its growth to an industry-leading Fortune 500 company. Micron Technology is a world leader in innovative memory and storage solutions that accelerate the transformation of information into intelligence, inspiring the world to learn, communicate, and advance faster than ever. Micron also delivers the world's broadest portfolio of technologies at the core of today's most significant disruptive breakthroughs, such as artificial intelligence and autonomous vehicles. Today, Mr. Sanjay Mehrotra joins COMPUTEX to share with us how Micron will continue transforming the world using information to enrich life for all. Let's learn, imagine, innovate, solve, and gain insight on the technology trends of today and tomorrow from a true leader. Please welcome Mr. Sanjay Mehrotra.
Newton's first law states that an object persists in a state of rest unless acted upon by another force. Nowhere is this more true than with our data. Oceans of insight lying dormant, still, unengaged. And when idleness is the enemy of possibility, we revolutionize, we rethink, we transform. Because today's data doesn't just reside, it lives.
It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel
Micron is where data lives.
Yes, data lives, and its impact on each of our lives over the years ahead is going to be astounding. Consider this: children born today will never know a world without smartphones or digital assistants. They will be the first generation that may never need to learn how to drive an automobile because the automobiles will drive themselves. They will expect that medical cures can be found quickly and even tailored to the individual's particular biology. They will think it is quite ordinary to have instant access anywhere, anytime, to vast digital libraries of information, or to study virtually in a classroom on the other side of the planet. We are absolutely living in a transformative age. Good morning. My name is Sanjay Mehrotra. I'm President and CEO of Micron Technology. Before we get started, I want to acknowledge the devastating pandemic surge in several parts of the world. The entire Micron team and I are absolutely heartbroken by the suffering COVID is causing our colleagues and communities in India and the new concerns and challenges the pandemic is bringing throughout Asia, including here in Taiwan. It underscores the need to remain vigilant and to always be ready to help one another. I do believe a bright future is ahead for the entire human race. But to get there, we must all work together to confront the collective challenges we face. And we must do so with absolute urgency. And we must do it together. So now, let's talk a little about the opportunity ahead. Micron is the world's fourth largest semiconductor company and the largest international investor here in Taiwan. Our memory and storage innovations have been at the heart of computing systems for more than 4 decades. Today, I will show you the trends that are converging to create opportunity unlike anything I have seen over my 40-plus year career in the technology industries. Today's economy is unquestionably based on data, driven by the innovative technologies that make that data more accessible, more effective, and more useful. McKinsey projects that advanced data analytics technologies will add $13 trillion, yes, $13 trillion to the global economy by 2030. All that added value is driven by our ability to make better and faster decisions based on the information all around us. But how do we make the best use of the enormous wave of data that we have only begun to create? Current computing architectures simply cannot digest data quickly enough. We need new computing approaches. For years now, the foundational approaches to data-intensive computing remain largely the same. We advanced through iterative improvements, and we did it so regularly that it became routine. But timely data insight cannot be achieved with today's memory and storage system architectures. Workload-optimized architectures are exploding as computing designers approach new challenges differently, using accelerator cards and GPUs to get faster data insight. Bespoke processors are becoming commonplace. Data is creating newfound opportunities for platform innovation, innovation that is occurring more rapidly than ever before. We are at the dawn of a new age for data-intensive computing. 2 major trends are accelerating this change and driving it forward: artificial intelligence and 5G networks. These 2 trends interlock, each providing fuel to the other to create dramatic new potential for data in the post-pandemic world. First, let's consider AI. By the end of 2024, it is estimated that 75% of organizations will have shifted from piloting AI solutions to operationalizing them. That shift is driven by the impressive gains AI can provide across all businesses and industries, from breakthrough medical cures to natural language processing. And unexpected industries are also using AI to solve real problems. Let me give you 3 examples. First, farmers are using real-time data analysis for everything from weed control to crop health monitoring, improving yields, and our global food supply. For farming alone, the AI industry is expected to be worth multiple $billion by 2025. Second, partnerships between machine learning experts and academic researchers are also making strides toward better water conservation. Advanced data analytics is already helping us understand how weather patterns, water usage trends, and the impact of environmental changes combine, giving researchers the insight they need to predict water shortages and help manage this precious resource. And third, Micron's talent acquisition team is employing AI systems to identify and eliminate unconscious bias in our hiring systems, ensuring that we have diverse interview pools made up of only the most capable candidates. The second major trend that is shaping the future of computing is 5G networks. 5G's growth has been one of the most anticipated trends in technology. And while the pandemic did hamper 5G network growth in many parts of the world, it is bouncing back strong. Over the next 5 years, in fact, operators globally are expected to invest nearly $1 trillion in 5G cellular networks, with individual 5G connections growing to reach 1 billion in 2023 and then doubling to nearly 2 billion by the end of 2025. Those networks will, of course, connect the feature-rich smartphones, mobile clients, and PCs that have become central to modern life. But even more exciting, 5G's ultra-high bandwidth capabilities and multitude of connections will enable an intelligent infrastructure on the edge of our networks. Moving data center-like capabilities to these edge networks will enable new efficiency, giving us access to data in real time, data that we simply aren't able to make use of today. Data is at the heart of the revolution that AI and 5G connectivity enable. And all this data comes to life through innovations in memory and storage, the semiconductor solutions Micron develops and manufactures. Micron is absolutely at the heart of this technology transformation. But it's not just us. These trends represent a major opportunity for the entire industry. This growth and transformation presents an opening for technology innovation to create infrastructure and platform differentiation that delivers bold new solutions for consumers. Solutions that will range from powerful data center servers to intelligent edge network infrastructure to smarter, faster, and better connected client devices. I've invited several of our closest partners and customers to share how our collaborative innovation will address this opportunity, both today and into the future. Let's get started. First, data center. With the rise of AI as a tool, nowhere is there more need for data-intensive computing innovations at scale than in today's data centers, in both the public cloud and on-premise. From enterprises seeking a competitive edge to hyperscale providers delivering the next world-changing digital service, data centers are more and more the backbone of our society. During the pandemic, data center computing kept us connected in critical ways that were unimaginable only a few years ago. Face-to-face meetings became Zooms. Trips to the grocery store became online ordering. Learning transformed to online experiences, and video streaming exploded. And while we expect these society-changing services to become part of our new normal post the pandemic, the industry is just beginning to realize the opportunity data center insights can deliver. According to IDC, at least 90% of enterprise applications will embed AI by 2025. And this rapid transformation of application places incredible stress on today's computing architectures. Speed and quality of insight derived from training AI algorithms or from large-scale analytics are literally being defined by the size of data sets available for analysis. Because those data sets must be accessed and processed so quickly, the time and energy cost to move data back and forth to storage, even fast storage, is too great. Today, those applications are being gated by the infrastructure's ability to fuel them from system memory. Because of this, memory and storage are becoming central to platform innovation. And we are excited to share that our industry-leading 1-alpha DDR4 is validated on leading major server platforms, giving end users access to the latest DRAM technology to fuel their data-centric workloads. However, there is also a new DRAM transition on the horizon, one that must deliver more than just a generational performance bump. When the industry defined the next standard for DRAM innovation, it centered that innovation for the first time on data center requirements, not client platform needs. With current memory at its limit, DDR5 is an important platform innovation delivering much needed advancements in memory bandwidth, density, and data center capability. In fact, when DDR5 arrives in platforms, we expect to see a doubling of memory bandwidth compared to the previous generation, which is essential to feeding the growing compute cores in modern data center platforms. For the first time, on-die ECC and fault bounding will enable us to scale density to new levels while at the same time meeting customer reliability, availability, and serviceability requirement. As a lead developer of DDR5 specifications, Micron saw the opportunity early in DDR5 standard development. This is why we launched the DDR5 Technology Enablement Program, or TEP, to help get the entire ecosystem ready for DDR5 platform integration and optimization. TEP provides early access to technical support, including sharing electrical and thermal models, as well as early DDR5 products to aid in design, development, and bring up of next-generation computing platforms. Today, we are excited to announce that more than 250 design and technical leaders from 100 companies are using our critical enabling support to accelerate industry readiness for DDR5 platforms. Let's look at how DDR5 fits into the suite of memory innovations aimed at the data center. The delivery of DDR5 is just the first step in a vast transformation of data center memory and storage. Applications are demanding innovation across the memory storage hierarchy. Micron is driving DRAM innovations for near memory, like HBM and DDR5, at the pinnacle of performance. We have also been a leader in delivering data center storage for the highest performing applications with our NVMe and SATA SSDs. We have a number of exciting new data center NVMe drives now under development, which are poised to drive the next generation performance needs of cloud computing. We have also worked with partners such as HPE and Lenovo to support enterprise QLC SSDs for hard drive replacement in warm storage applications. But between that near memory and fast storage, we see great opportunity for an entirely new tier of far memory solutions. So what is far memory? Far memory has been targeted by the industry to address the fundamental bottleneck in CPU-centric platform design. It will deliver a breakthrough in memory access for data center application requirements. The creation of the far memory tier is at the heart of a broad platform transformation being brought about by an open industry standard called Compute Express Link, CXL. CXL has gathered broad support due to its capability to provide the architectures critical to run AI workloads at scale. The connectivity CXL provides allows for new degrees of freedom for our platform architecture via shared pools of far memory. Platform architectures must be flexible and scalable to meet the needs of data-intensive workloads. Future data centers need heterogeneous compute and a reimagined memory and storage hierarchy. CXL ties them both together, putting memory at the center and enabling fully composable systems that can evolve with workloads. Of course, we cannot deliver data center innovation on our own. I've invited one of the world's leaders in data center compute to share his view on this once-in-a-generation opportunity. AMD's CTO and Executive Vice President for Technology and Engineering, Mark Papermaster.
Thank you, Sanjay. I appreciate the excellent collaboration between AMD and Micron and the opportunity to join you today and share a few thoughts on our industry. Modern data center workloads are driving new requirements for infrastructure, and it takes an ecosystem of innovators to work together and solve some of the biggest challenges facing the industry. There's an insatiable demand for more memory and more compute capability and capacity. The introduction of DDR5 DRAM and advances in platform interfaces like Compute Express Link or CXL are important milestones to meet customer needs. DDR5 brings even greater memory bandwidth to feed high-performance compute engines, enable energy efficiency improvements, and support efficient high-density computing for a variety of workloads. AMD joined the CXL Consortium in 2019 as part of a broader effort to utilize new and emerging memory and storage technologies in an open standards-based solution. CXL targets heterogeneous processing and memory systems across compute-intensive workloads. It will spur platform innovation and an ecosystem of flexible, tailored memory solutions in the next generation of servers. At AMD, we have a relentless drive for innovation in high-performance computing, developing CPUs, GPUs, and systems, all with an open ecosystem approach. We are a leader in accelerated computing, offering some of the world's highest performing server CPUs and the fastest HPC GPU for the data center with Instinct MI100. Our technology is trusted to power the most demanding supercomputers. Moreover, our strong product lineup meets the growing needs for data center workloads in the cloud as well as enterprise. We have a long history of collaboration with Micron, and continued memory technology innovation is key to meeting the demands for compute-intensive workloads. We are proud to work with Micron to power solutions for the modern data centers for both today and the emerging workloads for the future. Thanks very much.
Alongside this huge transformation underway in the data center, we are also seeing faster 5G networks ushering in ever more capable edge devices. This means we have the ability to process more data on the edge. Computing is moving from data centers to centers of data. That data-centric shift in capabilities means sharper insights and faster decisions. The industry is recognizing the importance of the edge. Edge is on the rise. According to IDC, 73% of enterprises view the edge as a strategic area of investment. The edge is driving economic opportunity across sectors, expanding services closer to the customer to make more efficient use of apps and data. These augmented cloud services will be hosted at edge network locations. Enterprises see the edge enabling their ability to deliver services now that they couldn't before. These include services as varied as more accurate forecasting of retail inventory, faster processing of large healthcare images like MRIs, autonomous platooning of truck convoys, and more immersive cloud gaming. The two macro trends I mentioned in my introduction earlier, AI and 5G, are absolutely fueling the growth of the intelligent edge. They're enabling the transformation by extending distributed data-centric computing models into new environments, including industrial applications and enhanced automotive experiences. There is a tremendous growth opportunity in the industrial segment. Micron has provided leadership across IoT verticals like factory automation, visual analytics, machine-to-machine communication, smart grid, and even aerospace applications. On the visual analytics front, we have a great edge example in our own semiconductor factories. Micron uses advanced optical inspection equipment to spot defects on wafers as they are being processed. Our artificial intelligence-driven auto defect classification system uses deep learning to sort and categorize millions of images every day. We also use thermal imaging in the fabs. We take images during normal workload conditions and overlay them on images from the fab's digital twin. These maps give AI systems a baseline against which to compare the infrared images. When the systems detect a deviation, they automatically compensate or disposition to ensure the highest levels of quality and yield in our production. Another industrial use case for predictive maintenance is for the aerospace industry. Edge computing helps filter and aggregate data collected in flight before transmitting to the servers on the ground. By sending selective data from the aircraft, it becomes feasible to do real-time analytics for the predictive maintenance. Intelligence at the edge can help determine what data should and should not be transmitted. This minimizes network bottlenecks and establishes data analytics at the most cost-efficient and latency-appropriate location. Security also remains a key concern for enterprises around the world as edge devices multiply. Micron's Authenta greatly simplifies the ubiquitous integration of security into connected devices, enabling over-the-air services. A great example here is our partnership with Tata Communications to offer a cloud-based eSIM for IoT. This worldwide cellular-enabled connectivity solution will simplify and accelerate large-scale global deployment of IoT devices. It's a pervasive end-to-end solution for zero-touch onboarding of connected IoT devices to cloud services across 200 countries and territories, backed by Tata's relationships with more than 600 mobile network operators worldwide. The automotive space is another important edge segment. It's undergoing a fundamental transformation that has not been seen since the introduction of the automobile itself. Today's cars have evolved into virtual data centers, processing and storing massive amounts of data, and demanding some of the highest compute and storage performance. For 30 years, Micron has been a leader in this market, with best-in-class automotive memory and storage solutions for in-vehicle infotainment, advanced driver assistance systems, autonomous vehicles, and functional safety. The automotive experience is increasingly dependent on fast and reliable computing with greater demands throughout the vehicle. Enriched cabin experiences depend on an increasing number of dynamic, personalized, and high-resolution displays. Many include AI-enhanced capability like voice, gesture, and facial recognition. Telematics systems provide continuous connection for passenger devices and also handle critical vehicle-to-vehicle communication. And autonomous driving and assistance features demand some of the most data-intensive solutions as they analyze an ever-changing environment to make split-second decisions. I'm excited to feature one of our closest OEM partners, one that is rapidly adapting their designs to these new opportunities in transportation. Micron has long worked with BMW in our customer labs to help ensure the semiconductor systems throughout auto cabins deliver a flawless driver experience. I'm pleased to welcome Dr. Karsten Regent, Senior Vice President of Digital Purchasing and Supplier Networks at BMW, to discuss why technology systems have become so central to the automotive experience.
BMW is committed to deliver outstanding customer experience, including advanced driver assistance functions, first-class infotainment experience, as well as telematics and e-mobility. Life-saving features like collision warning, lane keeping, blind spot detection, or vehicle-to-vehicle infrastructure, just to name a few, deliver a substantial contribution to improved road safety and driving comfort to all BMW customers. On the same note, BMW continuously enhances the way drivers interact with the car. BMW Natural Interaction, I guess you know that phrase from us, allows control either by touch, voice, or triggering a reaction with gesture or facial expressions. BMW will be the first OEM to provide 5G connectivity in the market. Besides using the bandwidth for high-definition maps, novel use cases like online entertainment are available to passengers. The digital experience is increasingly a factor in the purchasing decision. Furthermore, the transition to e-mobility will support the transition of societies towards CO2-friendly transportation and will be key to our success. The introduction of the BMW iNext will be launched in 2021 and will set a new standard in all those aspects. Advances in electronic devices fuel new product offerings from a functional and from a cost perspective. BMW is eagerly working with a supplier network in order to come up with leading-edge solutions. Our cooperation with Micron helps us to build leading-edge products based on a rich product portfolio, reaching from DRAM to non-volatile memory solutions. An active dialogue facilitates Micron's ability to develop product features like functional safety, security features, or enhanced diagnosis that help master the challenges of ADAS and infotainment systems. A deep integration into the development and industrialization process allows us to introduce innovative products faster and in a more stable manner.
With these coming automotive requirements and experiences in mind, today we are launching the world's first automotive qualified Universal Flash Storage 3.1 solution. Our ruggedized automotive storage is engineered to handle data-intensive in-vehicle infotainment and ADAS systems at the edge. We are introducing 128 and 256 gigabyte densities as part of the company's new portfolio of UFS 3.1 managed NAND products for automotive applications. With 2 times faster read performance than its predecessor, UFS 3.1 enables fast boot times and minimizes latency for in-vehicle infotainment and advanced driver assistance systems. UFS 3.1 also provides faster sustained write performance for these products, which is critical for local storage of the growing sensor and camera data required by autonomous systems and black box applications. In developing all our automotive solutions, we work closely with partners across the ecosystem. I'm pleased to introduce Nakul Duggal, Senior Vice President and General Manager of Automotive at Qualcomm, to talk about the role they play developing processors for critical automotive applications and why the speed of data is becoming more and more important.
First, I want to thank Micron Technology for inviting us to speak with you today. It's a great opportunity to share our thoughts on the ongoing transformation of the auto industry, our continued partnership with Micron, and how their leading memory solutions enhance the driving experience today and in the future. As you know, we are entering a new era of automotive innovation. And while the industry's first 100 years was marked by brilliant mechanical innovations, the future will be driven by evolving technologies in electrical architecture. Modern cars now feature an entire layer, an entire ecosystem of very complex hardware, software, and controllers that we refer to as the digital chassis. Going forward, it's this digital chassis that will power and deliver nearly all of the advanced safety, convenience, infotainment, and connected smartphone-like experiences that tech-savvy drivers will demand. In addition to the digital chassis, we see areas like centralized controllers, zonal architecture, and software-defined vehicles as technology trends that are gaining traction in the industry. We believe these terms and trends are really a response to 2 things. First, the industry's rapid pace of change driven by technology, and second, the growing pressure on automakers, their technology partners, suppliers, throughout the ecosystem to develop powerful, scalable, and cost-effective solutions to deliver next-generation in-vehicle experiences to the widest range of cars and consumers possible. As you can imagine, it's a huge challenge. And while Qualcomm offers a wide range of high-performance telematics, connectivity, cockpit, autonomous driving, and car-to-cloud solutions, these technologies require advanced storage and memory capabilities as well. That is why we have worked with Micron to integrate their storage and memory solutions into our Snapdragon 5G cellular V2X digital cockpit platforms, as well as our autonomous driving platforms. And we look forward to expanding our working relationship with Micron across even more of our automotive solutions. Thank you for watching, and thanks again to Micron Technology for inviting us here today.
As you can see, automotive systems require fully integrated technology solutions. Delivering to demanding auto specifications requires real-time syncing of core capabilities across component vendors and integrated solution providers. Micron has fostered incredible relationships over the last 30 years, which allow us to deliver unparalleled value in automotive sector. These relationships, coupled with deep technology understanding, pave a path for Micron to continue to introduce new innovation as this sector transforms. In an industry that has been challenged by near-term supply shortages, Micron is working in close collaboration with our partners to make sure that we can continue to provide critical memory and storage solutions to our customers. The final market I want to talk to is client, the devices that have been part of our working, learning, and playing for decades. But the pandemic has driven a new emphasis on the importance and role of these devices. Micron has been providing solutions to the PC ecosystem for 40 plus years, delivering high-performance memory and, more recently, fast storage solutions. Our technology is critical for fueling client computing cores and managing the dramatic increase in data in these devices. During the pandemic, the world discovered how essential these devices are to so many aspects of modern life: work, education, even connecting with friends and family far away. Over the past year, the demand for personal computing devices has soared. The boom in learn and work from home has boosted the need for more devices and better performance for live video connectivity. With many beginning to return to the office, there will be a new wave as businesses refresh older equipment. Not surprisingly, during this last quarter, the PC market reported its strongest year-over-year growth in 2 decades. One of the fastest growing areas in PCs is the thin and light segment, both for high-performance 2-in-1 laptops as well as entry-level Chromebooks, which are so critical to the modern classroom. As laptops have become thinner and lighter, we have continued to innovate in order to push the envelope in both memory and storage performance. Two of the most important advancements in storage are our 176 layers NAND and our QLC NAND technology. These have equipped SSDs with capacity and performance in smaller storage form factors. We have also introduced industry-leading low-power DRAM solutions based on our 1-alpha process, offering higher memory performance and lower energy consumption. Today, I'm excited to introduce further innovation in both our storage SSDs and low-power DRAM portfolios to help enable these devices. We are announcing the availability of 2 new PCIe Gen 4 solid-state drives built on our 176-layer 3D NAND. These SSDs provide high performance and design flexibility with low power consumption for fast responsiveness across the client market, from professional workstations to ultra-thin notebooks. Both the 3400 and 2450 SSDs offer very small form factors to enable increased battery life and smaller and lighter notebooks. I'm holding a very impressive feat of innovation: 1 terabyte of high-performance 3D NAND in a stunningly small 22 by 30 M.2 form factor. This tiny SSD can store countless user photos, programs, and videos, and serve them up quickly and effortlessly. This sleek storage device delivers 64% higher read performance than the prior generation and 40% lower slumber power consumption. It is engineered specifically for high-performance, thin, and light notebooks. Micron has a long legacy of delivering advanced memory for personal computing. We are pleased to announce today the world's first low-power DRAM on the leading 1-alpha node. We have worked closely with the PC ecosystem worldwide to enable this new technology in PCs, and we have enjoyed particularly strong relationships with our partners here in Taiwan. I'm pleased to welcome Acer Chairman and CEO Jason Chen to share some of the change they are seeing in client performance demands and the importance of their products today.
Thank you, Sanjay. 2020 was a historical year impacted by COVID-19. It was disruptive to the PC industry as customer demand accelerated due to a shift to home-based compute for work and for school. Homeschooling in particular spurred a more than 100% increase in demand for Chromebook PCs, which drove new requirements for low-power memory to build these systems. Our partnership with Micron for this critical DRAM technology was instrumental to our ability to rapidly react to this shift in demand. Acer appreciates Micron's customer focus to accelerate timely and sufficient support for our memory needs. The Chromebook program is one of the greatest collaboration between Acer and Micron. Acer delivered more than 5 million units of Chromebook devices in 2020 and will nearly double that number this year. This great achievement is significant for both Acer and for Micron, not only for growing the business, but also for our roles in supporting a worldwide community in education and learning. Competing in PC business requires companies to move quickly to adopt the latest technology for customers. In 2021, Acer is working closely with Micron to introduce their most advanced 1-alpha DRAM process node in the fastest DRAM system from Acer. This technology innovation enables our partnership to provide high-performance and power-efficient personal computers across the world. Thank you.
Beyond work and learning, consumers are using the PCs more than ever for gaming. IDC estimates that in 2020, shipments of gaming PCs and monitors grew nearly 27% to an impressive 55 million units. Micron continues to be a leader in this market. Our broad range of memory and storage solves for gaming's high definition and responsiveness requirements. GDDR6X is the fastest discrete graphics memory in the world, enabling high frame rates and resolution for the most immersive gaming experience. That brilliant performance is the result of years of close partnership with GPU experts. Our consumer memory solutions offer high-performance upgrades for gamers hungry for a competitive advantage. Our Crucial SSDs are built using the most advanced 3D NAND and are tuned to optimize gaming performance. This great performance has helped make Crucial the #1 brand of consumer SSDs in Japan for the last 2 years. We will continue to innovate in this space. In fact, with DDR5 on the horizon, we are working very closely with our CPU and motherboard partners to ensure an easy transition to this exciting new generation of memory. Of course, all of these great advancements rely on foundational semiconductor manufacturing processes. It is semiconductor manufacturing technology and process techniques that allow us to advance these solutions to process and store exponentially more data in less space while using less power year after year. It is a never-ending sprint to continually break through barriers that seemed unsurmountable just a few years before. Micron has long been a tenacious innovator in memory process, often surprising bigger competitors with breakthrough technology leaps that enabled us to hold our own in a very competitive industry. This year, I'm extraordinarily proud to say that we took a leadership position in both DRAM and NAND process technologies simultaneously for the first time in our history. Our 1-alpha DRAM and 176-layer NAND are the most advanced memory and storage technologies in production today. This leadership is the result of intense focus by an extraordinarily talented team and years of invention and discovery. Let's talk a little further about what these achievements mean. Our 1-alpha DRAM is the smallest line width geometry available in the world today. Producing this industry-leading technology requires highly specialized tools, utilizing precision materials, and operating in enormous, ultra-clean fabs. And this technology is produced right here in Taiwan, in our manufacturing operations in Taoyuan and Taichung. DRAM is essential to so many applications, as you have seen today, and we continue to scale our leadership technology to achieve even more advanced solutions. Our 176-layer NAND is a breakthrough in storage technology, the most technologically advanced NAND in the market, and Micron's fourth generation of stacked design. To achieve the capacities that can store terabytes of your photos, videos, and music, Micron's flash technology stacks data cells in hundreds of layers, providing space for billions of bits of information on a single chip 5 times thinner than a piece of paper. And I'm proud of these technologies, not just from a competitive perspective, but because of what they enable in our end solutions for customers around the globe. Transitioning our low-power DRAM, a memory used in millions of mobile devices, to our 1-alpha process technology creates real end-user benefits. Our 1-alpha DRAM designs will allow up to 20% reduction in memory power use, making a real difference in mobile battery life. One of the keys to Micron's success is a close collaboration with our partners and vendors. I invited Gary Dickerson, CEO of Applied Materials, one of the world's premier vendors of semiconductor manufacturing equipment, to share how they collaborate with Micron to create breakthrough semiconductor innovation.
Over the past 50 years, advances in semiconductor technology have made electronics more powerful and more affordable, transforming the way the world works and opening new avenues to economic opportunity. But what comes next is bigger and more disruptive than anything that's gone before. The digital transformation of the economy is the biggest inflection of our lifetime, and it will change everything, every industry, every aspect of our lives, and the very foundation of competition. And digital transformation depends on semiconductors. At Applied Materials, we know how to create and modify materials at atomic levels and at industrial scale. Our materials engineering technologies are used to make virtually every new chip and display in the world. Over the years, our great partnership with Micron has driven breakthroughs in chip making to advance modern computing. We collaborate closely with Micron's teams of scientists and engineers as they push the boundaries of physics and material science to make possible higher performance and more energy efficient devices. And today, we're just getting started. We're working side by side to create next generation AI-enabled digital infrastructure. We're combining sensors, metrology, data science, machine learning, and simulation to shorten product development cycles, optimize output, and accelerate time to market so the world gets amazing new products even faster. In the semiconductor industry, we're in a privileged position to shape the future. I believe that our job as industry leaders is to make the world a better place, and all of us at Applied Materials look forward to continuing that journey with Micron.
All of those advancements rely on our worldwide team for implementation. Micron has manufacturing and design locations across the globe, from Boise, Idaho, to Hyderabad, India, Munich, Germany, Singapore, Hiroshima, Japan, and several here in Taiwan. We have labs everywhere our customers are, and we work closely with them to integrate new solutions. One of the advantages of our global presence is Micron's ability to serve customers worldwide and mitigate regional supply chain risk. The past year proved more than ever before the importance of resilient, distributed, and diversified supply chain. Any business that hopes to compete and win on a global scale must prioritize supply chain resiliency and risk mitigation. We work closely with our customers and their extended supply chains to ensure that we know as much as we can about end customer demand. Real-time secure information exchange, advanced scenario planning, and simulation allow us to respond quickly to changes in demand or new risks, ensuring our global manufacturing network can respond quickly. That global network includes a significant presence here in Taiwan. Our team here are helping lead some of the most critical projects for the company. But before we get into that, I want to share a little about how proud I am of this team's competitive spirit and love for their community. Micron's culture places a high value on giving back to our community, and our team in Taiwan is a great example of that. Nearly 80% of our team members here volunteered or donated already this year, a great accomplishment for any large public company. These volunteers cleaned beaches and parks, raised funds for local charities, and helped map rural communities to improve emergency response during a crisis. Their efforts added to the corporate outreach of our Micron Foundation to support youth STEM programs, university education, and research partnerships in Taiwan, which totaled nearly 12 million Taiwanese dollars in 2020. The strength of this team shows in our business results too. Our major fabs in Taoyuan and Taichung have become a center of excellence for our DRAM technologies. In fact, this year, we made a significant investment to expand our fab in Taichung. We refer to the new clean room as A3, and it is a critical part of our strategy to respond to the data opportunity ahead. The primary purpose of this new clean room facility is to enable future manufacturing transitions of our industry-leading DRAM. In fact, our industry-leading 1-alpha was developed and ramped to production here in the A3 fab. Increasingly complex DRAM architectures require more processing steps and more advanced technologies, and as a result, more clean room space to deliver cost-effective and high-capacity memory. The A3 expansion builds on the infrastructure and manufacturing expertise we have established here in Taiwan. This new facility is now operational and will have a formal grand opening celebration later this year. A3 is physically connected to our existing Fab 16 and part of a mega site that includes back-end semiconductor package assembly, test, and fulfillment capabilities, a true vertical integration. This vertical integration accelerates our decision-making, increasing innovation and collaboration, and ensures ongoing DRAM leadership capability while fulfilling our customers' requirements. This expansion is another example of the long and successful partnership Micron has enjoyed with the Taiwanese government. We share a common goal to create and grow opportunities for local talent and promote a strong semiconductor industry ecosystem. Our manufacturing approach here also includes implementation of the latest AI tools, some of which I mentioned before. These smart control systems and predictive maintenance improve production efficiency and increase automation. Our process integrates an Internet of Things analytics platform with AI automated real-time diagnostic capabilities. This network collects petabytes of in-house manufacturing data from more than 8,000 sources. The data is housed in hundreds of servers around the world, allowing our data scientists across the globe to scour it for insights to develop AI models that will further improve our processes. Let's take a look at this site. It is a truly impressive structure, and what's even more amazing is how the construction was completed on schedule despite the challenges the pandemic posed over the last 15 months. This expansion also demonstrates Micron's commitment to reduce our environment footprint. A3 is the world's most advanced DRAM fab, both in technology leadership and sustainable operations. Consider the following. The A3 clean room is the first Micron facility fully designed according to our sustainability goals. The campus is covered with 600 plants. That's about 30% of the total area. The rooftops are solar-enabled and designed to harvest rainwater. A3's power-efficient design will save 90 million kilowatt hours of energy annually. That's enough electricity to power 18,500 Taiwan households for a full year. And perhaps most importantly, given the deep drought we saw this year, A3 is capable of reusing and recycling 75% of its total water consumption, saving enough water annually to fill 6,500 Olympic-sized swimming pools. The completion of this expansion reinforces Micron's commitment to lead next-generation DRAM technology development here in Taiwan. We truly are living in an age of nearly limitless potential. Our ability to better gather, understand, and make use of data all around us will provide opportunities that were not available and sometimes were not even imaginable just a few years ago. As those opportunities open up, we believe they come with a responsibility. Micron's vision is to transform how the world uses information to enrich life for all. These data platforms can be truly transformative to the human experience, providing better decision-making, more equal opportunities and access, and a safer, more efficient world. The entire technology ecosystem must work together to build systems that are capable of reaching the great potential. Micron is committed to being a strategic partner with our customers and industry enablers, driving data innovation across all end markets and applications. We see a huge opportunity for memory and storage to play a greater role as our engineering teams work closely to influence architectures across platforms to ensure the most efficient and effective access to valuable data. In the end, the innovation we create is driven by the ideas and expectations of you, the end customer. So my call to each of you today is this: keep dreaming, keep inventing, keep pushing technology to make life better for all. It is your ideas that drive our industry to break through barriers. With your help, we can take these powerful new technologies and create a safer, more comfortable, and more just world for all. Thank you.
What do we mean when we say all you need is an idea and Intel inside? That in today's fast-moving, high-tech world, big ideas are powered by a one-of-a-kind partnership with Intel, because our customer-first approach is more than just a byline. From the moment we put the silicon in Silicon Valley, Intel has been accelerating the industry in big ways, setting a course for a new era of bold innovation. No one else is this obsessed with engineering a brighter future. That's why we're driving the industry's biggest inflection points, putting intelligence where it's needed most in ways that only Intel can. With a multi-architecture approach that empowers our customers to transform their businesses from the inside out. We're democratizing AI in big ways, combining software and hardware to open up new possibilities. And we're moving that innovation around the world at lightning speeds with our advances in 5G. Collaborating with global operators and creating a new vision for networks of the future. We're taking intelligence and bringing it to the edge. Accelerating business outcomes with over 30,000 edge-to-cloud solution deployments. And we're taking that same innovation to the streets, deploying new technology and advanced data layers to make autonomous driving not only possible, but safe and seamless. Every day, we create world-changing technology that enriches the lives of every person on Earth. Making bold moves, because Intel has the unique portfolio breadth and depth, plus the global scale to serve as an unparalleled catalyst for our partners' biggest ambitions. So if you've got a big idea, let's go off and do something wonderful together.
Hi everyone, and welcome to COMPUTEX. I'm Nash Palaniswamy, Vice President and General Manager of AI, HPC, and Data Center Accelerators, Solutions and Sales at Intel. I'm excited to share some news and updates from all across Intel, today with a special focus on developments around artificial intelligence and high-performance computing. The opening video talked about a pursuit of big ideas. And if you saw Michelle's keynote yesterday, you know that all of us here at Intel are driven by the big idea captured by a very clear long-term purpose: to create world-changing technology that improves the life of every human on the planet. Today, I'd like to share how we are helping to make that a reality with the help of artificial intelligence and high-performance computing, which offers massive potential to impact the world in a positive way. Of course, the only way we can hope to achieve such an ambitious purpose is to work closely with the broadest and deepest set of ecosystem partners in the industry. Many of the longest and closest of those partnerships are with companies based right here in Taiwan. As a company, and in close coordination with our partners, especially our Taiwanese ecosystem, Intel is pursuing a world-changing purpose on multiple fronts through an unmatched portfolio with expanding capabilities to move, store, and process data in exciting new ways. Our multi-architecture roadmap is focused on accelerating workloads of every shape and size with a system-level architecture and innovative technologies that let users flex to a new level of AI and HPC performance. And with one API, it's finally possible to develop across diverse architectures with a single, open, standards-based platform. Today, I'm excited to share more details about a growing range of XPU architectures, starting with Xeon, the most broadly deployed CPU in AI and HPC. Xeon has been the workhorse of HPC for more than 2 decades, and more recently, it's played the same role for AI. Users trust Xeon because of this rich history. They've seen multiple generations of innovation, from vectorization, optimization to sub-NUMA clustering, and finally, to built-in AI acceleration in every CPU. Let's look at what new innovations the latest 3rd-gen Intel Xeon scalable processor family brings to the equation. For workloads that benefit from more compute, we have increased core counts and boosted instructions per clock, and applications that take advantage of Intel AVX 512 and other built-in instruction set will all see even greater acceleration. We've also enhanced L1 and L2 cache sizes and re-architected buffer and scheduler sizes to keep our execution units busier, which means you can extract more performance from your parallel codes. For applications that rely on fast data movement, our 3rd-gen Xeon Scalable 2-socket SKUs offer PCIe Gen 4 with up to 64 lanes for more and faster I/O. And our Distributed Asynchronous Object Store, or DAOS, which is part of the Xeon platform, delivers exceptionally high bandwidth and IOPS. For jobs where memory bandwidth and capacity are critical, we've increased memory channels and now support the new Optane Persistent 200 series with up to 6 terabytes of total system memory per socket. We're especially excited to see the impact for applications that already benefit from persistent memory, like OpenFOAM for fluid dynamics, using AI to analyze large medical scans that can't be downsampled, workloads that are simpler to run on a single node than distribute on many more. For multi-purpose systems that require different configurations for different workloads, only Intel delivers 3 configs in 1 CPU. Thanks to our built-in speed select technology, you choose from several different core count and frequency options, enabling more granular control over your AI and HPC performance. In addition, it's hard to believe, but Xeon is still the only x86 data center CPU with built-in acceleration for the fastest growing workload on the planet, artificial intelligence. Intel DL Boost technology with VNNI instructions speed deep learning inference and leverages 5+ years of extensive optimization for popular libraries, frameworks, and tools. 3rd Gen Xeon also delivers advanced security technologies, Intel crypto acceleration, Intel total memory encryption, enhanced cryptographic processing, and Intel software guard extensions, which enable a trusted execution environment with up to 1 terabyte of available protected space. As always, Xeon systems are easy to deploy and optimize, both on-prem and in the cloud with the development tools you're already familiar with. And thanks to our decades of software community engagement, commercial and open source codes are optimized to run exceptionally well on Xeon architecture. And finally, with one API, it's possible to develop across diverse architectures with a single open standards-based platform, a first. Of course, we love to talk about our own features and capabilities, but the real test is how Xeon stacks up against our competitors. Let's start with object detection, where our latest 3rd Gen 40-core processor delivers up to 25x performance versus AMD EPYC Milan 64-core. And since most data scientists don't run a single AI benchmark, we looked at a recent Kaggle survey and benchmarked a broad range of 20 popular machine and deep learning models, including training and inference. Across this broad set of AI workloads, the latest 3rd Gen 40-core has up to 1.5x higher performance on a geo mean compared to a competitor's 64-core. We did the same against the latest GPUs in the market and outperformed it by 1.3x for a broad mix of AI workloads. This is the benefit of DL Boost and AVX 512. Moreover, for HPC, the latest Xeon scalable processors also outperforms AMD EPYC Milan processors across a wide range of real-world workloads, including NAMD for molecular dynamics, where AVX 512 support again makes a huge difference, as well as Reliant for cryo-EM and Monte Carlo in finance. And stay tuned for even more optimized workload benchmarks at International Supercomputing later this month. Of course, the decision criteria for adopting critical new technology goes well beyond the basic metrics of speeds and feeds. In fact, one of the most valuable benefits of Intel Xeon scalable processors isn't even part of the chip. It's the industry's deepest and broadest ecosystem of optimized software for AI and HPC. An ecosystem we have helped nurture and evolve for decades, and a key component in optimizing total solution performance. From where you manage your data to open source and ISV tools and apps that you rely on for AI and HPC, Intel optimizations have you covered for the best out-of-the-box performance. Let's zoom in to take a look at a few of these software optimization benefits. There are many startups creating AI hardware accelerators, promising huge performance gains. But did you know that you can get a software AI accelerator? Take scikit-learn, the most popular machine learning library, for example. Simply installing the optimized Intel extensions can yield up to 100x performance at no additional cost using a Xeon architecture. Similarly, for deep learning, if you're not already using the Intel optimizations for TensorFlow, one of the most popular frameworks, you could be leaving up to 10x performance on the table. OpenVINO is another example, popular deep learning tool that is growing exponentially, thanks to its ability to easily deploy pre-trained models for deep learning inference across multiple hardware targets, from cloud to the edge. With optimal efficiency and almost no accuracy loss, OpenVINO can deliver up to 10x performance gains using DL Boost on Xeon. In HPC, our engineers collaborate with open source and commercial developers to ensure the applications run optimally on Intel architectures. For NAMD, an award-winning molecular dynamics code used extensively in COVID-19 research, our unique tiles algorithm running on 3rd Gen Xeon delivers an astounding 143% performance boost. If you are a financial services firm performing derivatives computation on a daily basis, a software tuned for Intel Xeon will be dramatically faster due to AVX-Y12. And thanks to our work with partners like ANSYS, engineers are able to accelerate their designs to bring safer, more performant products to market faster. But don't just take my word about Intel Xeon scalable processors. Let's look at how they're helping to improve lives through health outcomes with AI and HPC. In this case, we are a partnership with the Montefiore Medical Center.
Montefiore has always been very forward-looking about technology, about the uses of IT, the electronic medical record, looking at population health as instead of individual patient health, to be at the interface with science, technology, philosophy. It's just a really fun place to be thinking about all these things.
We have a patient who presented to me with myelopathy, dysfunction of the spinal cord. What we do right now is we look at the imaging and we try to identify whether or not a patient has a metastasis. What would be very powerful is for an AI-based algorithm to be able to actually identify patients with or without metastases, to screen patients based on their imaging. If we could identify these patients months, even sometimes years in advance, and really hone in on which patients are likely to develop this kind of paralysis, then we can really treat them earlier and prevent this from happening in the first place.
I believe that AI can really help not solve this problem, but help solve this problem in a sort of a incremental way. Part of our challenge is, how do you make AI invisible? So that it runs as fast as possible, that the doctors don't even know that there's AI running behind the scenes.
You need to build a system that really understands patients and get the outputs of those algorithms and integrate it into this holistic understanding of the patient. That's what we have been building at Montefiore. Patient-centered analytic learning machine is a system of creating a digital representation of patient from all of the data that we collect about the patient, from all of our devices, EMR systems, patients' own narratives when they talk to us, as well as data that we may collect through digital devices and remote sensing at home, and shares this holistic understanding of the patient with hundreds of AI models. Technology companies are now playing a huge role in redefining medicine, redefining healthcare. We think that the future for healthcare is going to be in the intersection of the traditional medicine, the way we know it, and a lot of technical advancement and innovation that will happen. And that's where we have been focusing on working with Intel.
The thing that sort of excites me about AI and healthcare intersection is because this is going to be a game changer for many industries, but healthcare is a place where you're actually going to make a difference on people's lives, and that to me is very powerful.
Thank you, doctors Eskandar, Yanamadala, Mirhaji, and team. Of course, we are not only focused on big iron, AI, and HPC computing in the cloud and data center. We're also improving lives at the edge in PCs and other devices. And just think how quickly some of these capabilities have gone mainstream. We are all benefiting these days from noise reduction, background blurring capabilities in video conferencing. You can easily transcribe meeting minutes from recordings. And if you're a creative photo or video editor, you can now instantly remove blurs, stylize videos, search your archives, and enhance content with a few clicks. And we're seeing innovative new applications using this technology, like personalized workouts that I hope can help lower my golf handicap. Let's hear from Zoom, a company that is synonymous with keeping us all connected through video conferencing by harnessing Intel's technology with built-in AI acceleration during this pandemic.
Zoom is known for our ease of use, video quality, audio quality, and performance in low bandwidth environments. We are also the pioneer in introducing virtual backgrounds for your mobile, your laptop, desktop, etc. And the virtual background actually provides privacy between your work and your home, given that most of us are working from home nowadays. To further enhance, Zoom also introduced video and PowerPoint virtual backgrounds, and lately the immersive view. All these features rely heavily on AI and deep learning inference in particular, which benefits from Intel Deep Neural Network Library on our Windows clients. Building on these innovations and technologies provided by Intel on the consumer and the commercial platforms, Zoom has introduced advanced AI background noise reduction to automatically reduce environmental noises such as fans, dog barking, vacuum cleaner, to make the meeting experience even better. We appreciate the flexibility and the performance optimization from Intel One API, as well as the video hardware acceleration. And we are looking forward to working closer with Intel on their new technologies and see how we can use them to innovate for our customers. Thank you.
Thank you, Velu. Let's also hear from Adobe, a company that is synonymous with creativity and is also harnessing Intel's technology with built-in AI acceleration.
Now, transferring large files is a major pain point for all creators. Whether we're transferring hours of content stored on external hard drives or simply moving files from one machine to another over Wi-Fi, transfer times translate to lost productivity. As part of our own AI revolution, Adobe has been working closely with Intel to ensure creators spend more time creating and less time waiting. The key, optimizing Adobe Sensei on Intel platforms. When I'm ready to create, I need a system that can keep up. I need a system that performs across my entire workflow, including import, editing, exporting in Premiere, creating effects in After Effects, and thumbnails in Photoshop. That's where Intel and Adobe's collaboration really makes a difference. They've optimized the system to be able to handle the creator's needs across the entire creative workflow. I was blown away by the performance. I mean, I could scrub 4K and 6K timelines in Premiere Pro with no lag, and Sensei was blazing fast when using auto reframe. With everything I've been hearing, I can't wait to get my hands on Intel's 11th gen system with XE graphics to really see what new performance improvements Intel has developed.
Thank you, Jason. Now, let's turn our attention to the full category of processors we call our XPU architectures. While Xeon is the most widely used platform for the broad set of AI and HPC usages, accelerators are key for larger scale and more dedicated training workloads. We offer the most variety of domain-specific AI accelerators, XPUs, built on the One API open standards for greater interoperability. If you're running a multitude of workloads where AI and or HPC are part of the mix, then the CPU with optimized software is the place to start. With Xeon from the cloud to edge, to Core from edge to device, to Atom in low-power devices. For high-performance computing deployments, where you often have a high percentage of data parallel workloads like AI, HPC, media, graphics, Intel Xeon processors with our Intel XE GPU discrete acceleration will likely be your best option from cloud to edge. We also recognize that for AI thought leaders, compute can be dominated by deep learning training. And for those applications, Habana acceleration in the cloud may be the best option. And for extremely low power deep learning inference at the edge, Intel Movidius VPUs are the best solution. Sometimes an FPGA could be a good option also. Finally, for custom deep learning, pathfinding and research, use Intel FPGAs. I'd like to invite some of our customers to explain why they opted for each of these different architectures to suit their unique AI and HPC needs. Despite not yet being launched, our XE GPUs have already been selected for major supercomputing deployments. including the Aurora project with the US Department of Energy. And as was recently announced, the SuperMerc NG Phase 2 supercomputer at LRZ. Let's hear from Professor Dr. Dieter Kranzmüller at LRZ about why they selected Intel's next-gen CPU and GPU for the upcoming supercomputer expansion.
Thanks, Nash. It's great to be with you virtually for COMPUTEX 2021. LRZ supports groundbreaking research and education across a wide range of disciplines. Our users tackle some of the most important and difficult computational challenges in the world today. Intel is a key partner in this effort. We build on Intel portfolio and we will integrate their diverse architectures and innovative memory and storage to ensure that LRZ is ready to support our HPC users' success today and tomorrow. We recently announced our plans to expand SuperMerc NG to address new demand across multiple fields, with physics and medicine to the humanities. This means even more powerful computing, to be sure, but also support for multiple XPU architectures and innovations in high-performance storage. For computing, Intel is providing the blended environment we need, with next-generation Intel Xeon Scalable processors, codenamed Sapphire Rapids, with built-in acceleration for new HPC and AI workloads, plus Ponte Vecchio, Intel's upcoming GPU. Since our users need to access data as quickly as possible, we'll be using Intel Deos for fast, high bandwidth, low latencies, and high IOPS storage on a system with third-generation Xeon processors and Optane persistent memory. It is exciting to plan how this will deliver improvements in diverse areas, from biomedicine to astrophysics. We're looking forward to see what new projects this system will make possible.
Thank you, Professor Dr. Dieter Kranzmüller. For customers who are looking for a 100% AI-based processor to push the limits of deep learning, the Gaudi and Goya processors from Habana, a new Intel company, offers high efficiency, scalability, and portability. And this led the San Diego Supercomputing Center to select them for the upcoming Voyager project. Let's hear from Sean Strandy, Deputy Director, San Diego Supercomputing Center.
Here at the San Diego Supercomputer Center on the UC San Diego campus, we're excited to be building the Voyager AI supercomputer, which will be a resource to the national research community through funding by the National Science Foundation. I'm Sean Strandy, Deputy Director of the San Diego Supercomputer Center and Project Manager for Voyager's design and deployment. Computational science and engineering are entering a new era where AI is becoming essential to advancing discoveries across every field of research. We chose Sabano Labs' Gaudi Accelerator for deep learning training and Goya Accelerator for inference because we believe they have the potential to dramatically improve the ease of use and reduce the time to discovery for researchers who are using AI. Gaudi and Goya were designed from the ground up for high performance, high efficiency, and scalable AI data center operations. When paired with the third-generation Intel Xeon Scalable processor, we'll have one of the most capable supercomputers on the planet. We're excited to bring Voyager to the community in support of a wide array of AI research projects in astronomy, climate sciences, chemistry, particle physics, and other such projects after the supercomputer launches this fall. We can't wait to turn researchers loose on Voyager with Intel's and Habana's AI compute capabilities.
Thanks, Sean. For customers looking for 100% AI acceleration for deep learning at the edge, especially where power is a constraint, the Intel Movidius Vision Processing Unit, VPU, product line is a great option. And let's hear from Aurangzeb Khan, Senior VP, Intelligent Vision Systems at Jabra, about why they opted for Intel's VPU.
Hi, I'm Aurangzeb Khan, the Senior Vice President of Intelligent Video Systems at GN Jabra, where our vision is to create an intelligent, more effortless collaboration experience for everyone. To make it a reality, we use Intel technology that extends outstanding AI performance to the edge. The Jabra Panicast 20 personal video conferencing device and the Jabra Panicast 50 intelligent video bar are designed to make collaboration more natural, engaging, and intuitive. To ensure our users spend their time focused on their work, not the technology, we turn to Intel and their Movidius Myriad X products to deliver power-efficient edge AI performance in a relatively small form factor. Security and privacy are top concerns in the distributed workplace, and the Edge AI processing capabilities in the Intel Movidius Myriad X product help us securely deliver the performance we need while transporting video and audio through cloud environments. Intel has been a strong partner with deep knowledge, reliable expertise, and an outstanding commitment to shared success. So they were the ideal partner for bringing the Panicast 20 and Panicast 50 to life.
Thank you, Aurangzeb. We are not just focused on the here and now of AI and HPC, but are investing heavily in the future. From dozens of R&D projects in Intel labs, to billions invested to acquire or fund startups, to multiple high-impact partnerships with leading research institutions such as Mila and the Intel Dell Open Exascale Lab at the University of Cambridge. We are leaving no stone unturned on the frontiers of AI and HPC. Whether you're a business, a builder, or a partner, Intel has a lot to offer. To learn more, please connect with us after Computex to work together. Our upcoming Intel On event in October is another great collaboration opportunity, and we look forward to seeing you there. Let's work together on the next generation of big ideas that will help improve lives through AI and HPC. Thank you.
Good day, everyone. I'm Charles Liang, President and CEO of Supermicro. It's my great pleasure to meet you again here at COMPUTEX, although online. Since COVID-19 is still threatening us, please be diligent to keep yourself, your family, and your coworkers safe. I'm very happy here to share with you the green computing advantages, the ways to be greener, its ROI, and how excited and proud to be a leading green computing company. As you may know already, Supermicro is first to market recently again, launching the broadest Intel Ice Lake, AMD Milan, and NVIDIA A100 GPU-based product lines. We have more than 200 application-optimized products shipping today, thank you to our almost perfect building block solution architecture. These optimized building block systems are created in-house with more than 2 decades of subsystem innovations, including motherboard, enclosures, power supplies, thermal solutions, security features, management software, and more. They allow Supermicro to design and deliver products quicker, much better application optimized, and more power efficient than those from our competitors. Indeed, our building block solution technology also makes managing our production and inventory more efficient because of its ability to share the same subsystem across many different product lines and different product generations. These building blocks keep our inventory low, while provide application optimized solutions to our partners with minimal lead time. Headquartered in Silicon Valley for the past 27 years, we work closely with all the leading technology partners. We design platforms together, leverage experience from each other, and review and validate products in real time. This advantage enables continuous product innovations with new features and improved performance. This partnership also result in our products having the best time to market, quality, serviceability, and compatibility across different generations of technologies. What else has Supermicro been preparing for our partners? The answer is our software and firmware offerings, as they are essential to any optimized total solutions. With more than 25 years of visioning, planning, and hard work, Supermicro today has one of the strongest firmware and software departments in the whole industry. With our broader system portfolio and optimized firmware and software, we are now capable of supplying your application optimized completed rack solution. The PMP rack provides turnkey, pre-validated rack level AI, 5G, telco, enterprise, and cloud solutions. This rack has undergone a thorough solution level design process with our partners, built securely and tested with precise L11 or L12 specifications.
Hello, it's a pleasure to be speaking again at COMPUTEX. My name is Michael Clegg, and I will give an update on the 5G market and the latest developments. My colleague, Moivi Lin, will speak about the latest product information and the new generation of products that we have. 5G network deployments are now well underway in many countries, initially in a non-standalone format, and soon which is really a 4G network enhanced with a 5G new radio. We are starting to see the first 5G standalone network deployments, and really it is with standalone networks that we get the real benefits of 5G kick in. For the core, we move to a cloud microservices orientated architecture using a CDCI deployment model. With a cloud-native architecture, the network adopts the principles of a hyperscaler network running on standardized COT servers. You can even run the core network on our cloud itself, which some people are starting to investigate. For the radio access network, after a pretty long gestation period, we are now seeing the broad adoption of Open RAN, which also has the objectives of running the RAN and COTS hardware. This is a bit more challenging given the signal processing requirements, and we are at a point where the method has been validated with 4G And with the latest processors, we can now achieve the same thing for 5G. 5G Open RAN has started with greenfield operators like Rakuten and Dish. We are seeing broader adoption by the traditional operators, especially in Europe, with the recent MOU that has been announced. We're also starting to see the predicted innovation and growth in the broader ecosystem, with more silicon suppliers, in addition to Intel, who pioneered the space, coming in with Qualcomm, Nvidia, and Marvell. We're also starting to see some startup vendors enter the market from a chip point of view, which really demonstrates the opportunity. And with that, I will hand off to Maury, who's going to explain to you some of the advances in the processors and Supermicro's latest product release.
Thank you, Michael. My name is Maury Lin, and I would like to introduce our innovation for the telco 5G RAN applications. Supermicro helping provide the best and optimized computing performance with accelerations design inside for vRAN application. We work closely with the worldwide vRAN partners, including in their deployment at the field sites with the worldwide lab engagement. We brought the data center performance to the edge. This changed a lot because the Intel 3rd generation Xeon SP processor make it possible to everyone in this vRAN architecture. And Supermicro in this architecture bring the solutions to the edge. Let me give you an example how to utilize this edge computing performance for operator to shorten their gap. Supermicro Hyper-E and Open RAN solutions. These solutions carry lots of features we learned from the market, and I'm going to bring you several features we learned and how we support to shorten the gap. The first one is about how we maximize the expansion flexibilities. We allow the operators insert more the wireless accelerator card, including Intel accelerators A1000. In this case here, it's using a Moonbright technology. Besides that, also the validated system design supporting the Intel FlexRAN and ORAN architectures as well. Not just about that, we also realize that NAPS Level 3 certification is very important for those infrastructures to protect their redundancy and reliabilities. We all have that certified with our DC power supply with the 1200 watt features ready inside. The workload also is the important topic we have to handle together. And as I mentioned already, with the CPU technology from Intel, it's possible to support dual processor architecture and also single processor architectures in this design. It's able to run up to 270 watt, so it's amazing. Then also we have to think about, in this environment here, front access is become a very critical requirement for the operators to make sure their IT people, their operation teams to serve this machine easily. And we design everything front access. And also considering the short depth in this environment here, we're offering two choices to you, including the 300mm and also 574mm depth. This is all designed for the front access in the space concerned area. We owe these possibilities the rack mount design for the 1U, 2U systems will help a lot. By integrating all this innovation together with our partners, and we dramatically shortened the gap of operator expansion to the 5G and telco vRAN. This let Supermicro continue the investments and to enlarge the contributions to the telco industry. Michael, back to you.
Thank you, Maury. Now that the 5G network is falling into place, the emphasis is how to monetize it. The real benefit of 5G is ultra-low latency. But to take advantage of that low latency, you really need to push the application computing to the edge of the network to what is known as MEC, Multi-Access Edge Compute. By co-locating the application edge processing with the RAN, any latency critical traffic can do a local breakout and go directly from the edge of the RAN network into the application space. Applications that benefit from this include AR, VR, video, robotics, mobility type applications that are sensitive. One of the most common edge applications is the combination of video and AI. And with that, I'll ask Maury to explain how we solve the problems of high-performance AI processing at the edge. Maury?
A great topic about the AI at the edge for the AIoT industry. We have a lot of engagement in the retail, smart city, and also Industry 4.0. Supermicro bring the edge computing into a wide variety of environments. And from central office to the micro data center to the cell tower and the factory floors, this meeting lots of the particular environments and operating challenged. And those requirements will be able to support it by the Supermicro new design hardware, including combining lots of accelerator together, such as a GPU, VPU, and FPGAs. We provide virtualizations to the edge. This build intelligence to the retail space. For example, we use the AI-based solution through the Intel OpenVINO solution. And this makes easily onboarding all our partners to our hardware and to solve the end-user pain point. The pain point is when they need a performance at the edge. To create a virtualization for the users, they need a high performance and reliable machine there. In the Industry 4.0 and also smart places, our partners not just provide edge computing virtualization, they also realize that we have to create a different installation format for them to fit into a different environment. Think about the spaces in the factory floors. You don't have a rack mount cabinet to put all your rack mount machines. You need to have a machine able to mount to the wall or stay on the pole. In the smart places area, this will require your computing power have to stay outside. So we have outdoor edge computing systems to support these possibilities. And we all make it possible for you. Because of this requirement here, Supermicro also bring our building block design DNA into the IoT edge computing design architectures. You could have all the performance through the lattice CPU, like how you enjoy the performance in the data center. Now we all make it possible at the edge. We design made in USA and also can accelerate your global deployment. The COVID-19 not just changed the way the people interact in the social network, actually also accelerate the way how people use informations. Then we believe this kind of demand will dramatically increase through the AI investment and also the edge computing. Because of this, Supermicro will be able to maximize your return on investments at the edge for the IoT space and also possible through the telco 5G area. So please grab this high chance of fast growth opportunity with the Supermicro. I will hand it off back to Michael.
Thank you, Mori. So to wrap up, we can see that 5G has been actively deployed both in public and in private networks. The promise of a cloud-native 5G network and Open RAN is being validated with innovations like network as a service, with programmatic networks being developed, and while we see that AI will reduce the cost of operating the network. We're also starting to see innovative AI-enabled edge applications of the examples that Mori gave, enabled by high-performance products like the Supermicro products that we showed. It's going to be a very exciting next few years. Thank you very much.
Hi everyone. Today we are very happy to invite you to join the keynote session here about 5G and telco. Announcement together with our X12 Intel 3rd generation Xeon scalable processor launch. In this session here, I would like to explain to you more why the innovations bring the customer's attention to Supermicro portfolio. I believe most of you are aware of the telco segments getting more and more open environment. One of the key topics is how to utilize the open radio access network to accelerate the 5G infrastructure's deployment. Because of this, we also realized the performance also need to require the same level like we deliver in the data center. For this kind of purpose, we redesigned the data center architectures extended to the edge. At this moment here, we have to think about what kind of a 5G telco at the edge requirement. First of all, you will have a different input from the power source requirement. And also, your accelerator requirements getting higher and higher for different workload combinations. For instance, you have to handling the signals from your user equipment and convert it into the Ethernet protocols back to the backhaul and data center. Because of this, the Open Radio Access Network and also ORED Alliance provide this chance to Supermicro. Besides of this kind of a requirement at the edge, we also realized that lots of accelerators require the performance stay the same like the data center level. For instance, like the GPU will help the inferencing at the edge. Supporting this 5G environment accelerate the application to the private 5G and other deployments. Make this possible is not easy, but Supermicro make it. So to make this story more detailed, I bring the several products in front of you here. We got a Hyper family this year. Want to announce to you. This product is a greatly designed tool list, so easily for you for the service. Enterprise customers like this to reduce their downtimes. The second thing is with the Hyper series, we are able to Gen 4 ready and also plan for the future Gen 5. Besides of that, we keep it compact and front access. Why front access matters here? Lots of the telco customers, they facing different workload environments. Some of them require the AC power input. Some require the DC power input. We offer both. Because of this, it's possible to let them scale quickly with the Supermicro building block solution for telco customers. In front of you here, the first product, you can take a look here. This product allows you to plug in 3 accelerators. These accelerators up to the double width GPU card as well. And then you immediately notice there's a different power source at the front. Not the typical one, the IT device, you have to access your power at the rear side. Not just about that, we're also offering the open compute form factor called OCP NIC 3.0 form factor, extend the network capability up to 400G. Right now in front of you here, you can take a look here. We're able to support you 2 slots. So this allows you to have accelerator on the top and also with the OCP networking module to accelerate your network speed. This is all possible for you in the very compact 22.6-inch depth, which is a telco perfectly fit into their cabinet at the edge. Besides of this point here, we also realized the customers, they have a different kind of workload, even closer to the rural area. At that point, they're expecting the system getting smaller and compact. And a processor, they're also able to reduce down to the single socket Xeon SP platforms. We also offer this to the customers. As you can see here, the black color here, this is also our latest innovation here. Inside here, it's a one single Xeon SP processor. Not just about that, we still keep the redundant power supply for you, DC, AC, both available front access. We're also able to support you 2 NVMe hotspot features at the front, which is good for your redundant feature, back up your OS and applications. We never sacrifice our performance of accelerators. You also can see the different accelerator card could be put on the top. Here are something we also want to let you know how closely working with the Intels and other accelerator companies. We put the eMon Bryce cards to help you for the FEC features, accelerate the 5G communications. We also have a different 25G networking port to handling the signal from RU all the way to DU and back to the CU part. This all the innovation here is a Supermicro building block for telco customers. And we also realized, once you got the very comfortable space at the edge, we are able to bring all your computing needs back to the data center. So that's also the reason why here you can see in front of you, the same design, we turn around and allow you to become another design, become a front access for all your hotspot feature through the fan and hard drive. Internally, the concept, you're also able to enjoy the performance and then become an innovation here for the IT infrastructures inside the data center, connect all the 5G together. This is just the beginning of our infrastructures upgrade. To more update to you, we also can tell you this year we bring the outdoor edge systems to you. For the outdoor edge computing, it's also be part of the important infrastructure to accelerate the 5G deployment, especially for private 5G. And also other areas require the computing closer to the edge. Because of this requirement, we clearly listen to the market demand. So we bring this outdoor edge computing system to the market. What we can do right now is using the Intel 3rd generation Xeon SP processor into the IP rating 65 level, able for you to dust and waterproof. And then in this case here, it's also allow you to drive the wide range temperature, minus 40 degrees C all the way up to 50 degrees C. Why we have to design a product like this? Because we, again, extending our data center technology to the outdoor edge computing. In this environment here, customer can using this to connect to their surveillance application, connect to their DU and RU accelerations. All this possible, the pole mount machines carry on together with all the accelerator I mentioned. Because of this all innovation, all cross-platform together, we are easy to help the telco customers. And also for this enterprise customers enjoy the 5G deployment. We are very happy to be here to introduce so many innovations for the telco customer here. Thank you for watching.
Hi, and welcome to Supermicro Tech Talks. I'm really excited to introduce Yaming Wing, one of our product managers for Supermicro's Edge servers. How are you doing?
I'm fine, thank you, Heather. Thank you for having me. So today I'd like to talk about our newly released Ice Lake server, purposely designed for the Open RAN market. And we have spent almost over last year to really purposely design this one to fit into the telco market to meet its function, environmental kind of conditions. We're very proud and very excited to share this product with you.
That's great. Could you share with me what Open RAN and O-RAN actually means?
Sure. Yeah, this is really all related to 5G, right? So for 5G, it's because there's a requirement for new bandwidth, and to achieve that, you have to use a higher spectrum, higher spectrum would require the base stations to be closer to each other. That means we will have to deploy more base stations than was already out there for 4G and 3G today. And because of that, the operators, they have to buy a lot of more servers. And today, for 4G and before, they only have a limited number of suppliers offer an end-to-end proprietary solution. They really don't like it. And also another problem for them to facing is they want to be able to run the cloud applications freely on their edge server to be able to bring the innovation from cloud to there. With all this proprietary design from the incumbents, they cannot do that either. That's why an open standard based on a white box, probably more on the x86 type of servers, is a solution for it. And that's why we're working very closely with Intel to make that a reality.
Excellent. So what do you have to show me right here?
So this is our sys210P server. As you can see, this is a 2U server. But one thing special about this server from the typical data center server you can is everything, all the I/O is in the front. And even the power supply is in the front for a specific reason. Because we designed this product as an on-site DU or distributed unit for telco guys. And typically they have an outdoor cabinet sitting under the cell tower, right? So this server has to be pushed in toward the end. There's nothing you can open from the back side. So every access has to be from the front end. So that's why it's very important. Another thing I want to mention also is the depth of the server. Because of some existing cabinet is really, really narrow, for they can only accommodate certain depths. We designed this one, this server is only 298 millimeter depth to really fit into that kind of environment. So it's very important for those things that I mentioned earlier, right, to meet the functional and the environmental requirement for the operators.
So those are really great features. What about CPUs and internals?
Yeah, so because we're running the telco workload on the servers, and Intel has specifically designed a SKU called N SKU for Ice Lake. N stands for networking, or NFVI. So in that SKU, the CPU can go up to 36 cores, go down to 20 cores. They specifically designed because they tested with some telco workload and also optimize for the thermal consumption as well. We have to accommodate that, especially because the server has to meet the temperature environment. For example, for 36 cores, we have to design certain heating, actually not the heating, to observe the heat functions to be able to make the server running with 36 core, but still can run in 50 degrees Celsius kind of environment. We can also run the server in a lower temperature, below zero environment as well to meet those kind of environmental requirement.
That's very impressive.
Another thing special about this server I want to share is, if you look at the front end, we have many different slots, PCIe slots, to fit into the add-on cards. This is very important because for a standard x86 server to be able to acting as a telco server, there are certain things like real-time processing and also timing function has to be covered by it, and even monitoring as well. So we leave enough PCIe slots for here. Basically, you can have 4 PCIe slots here. If you use a lower core, we can even open up in the middle, so we could have probably up to 6 PCIe slots for this server.
Very impressive feature set. You had mentioned that there are some add-on cards for the DU. May you share some more about that?
Sure. So this is really related back to the PCIe slots we have here, right? So the way we achieve those telco workload is through those add-on cards inserted into the PCIe slots. So one type of add-on card we call the acceleration card. It's a layer 1 networking acceleration card. And the most popular one we validated now is a Mountain-Bryce chip-based EAC card from Intel. So that will help with the 4G and the 5G protocol translation. Another type of card is a NIC card, networking card but it's not your average networking card because you need to have Grandmaster IEEE 1588 function inside it. Plus, we need to have a GNSS chip to talk to the satellite to get the timing. Because this DU box in the O-RAN type of world, many cases will acting as a Grandmaster, offering timing to the radio unit. And in case we're losing connection with the satellite, the server itself need to have a holdover time of the timing for 4 hours. So special OCXO has to be added to that NIC card to make that happen.
This is an amazing system. I understand that it's already been shipped to customers.
Yes. In fact, this one is in very high demand because we purposely designed it for the O-RAN type of DU out there. As you know, O-RAN is new, and DU as a standard of 5G is also new. So we're making that happen. We're one of the really early server vendors to build this type of server. One public information I can share with you, because there are many customers I cannot share their name yet. One I can share is Telefonica. So Telefonica, in January this year, they published a white paper talking about their O-RAN implementation. Inside there, they mentioned the Supermicro's DU, exactly this one, actually in the picture for their white paper, right? So we are helping them to realize their dream there. There are other customers, probably in the next couple of months, we're gonna announce more.
Awesome. So Yaming, it really sounds like Supermicro's really invested into O-RAN and making it into a reality.
Yeah, definitely. We have seen huge potential in this, and we're very proud to make this happen because to be able to have a really connected world, if we can contribute and make it a more open and connected world, that's really aligned with our company's mission. By having our server combining with Intel's CPU, IDOM card, and also our software partners combined together, we can realize it and make Open RAN a reality. So I'm looking forward for the day this have a massive deployment in the operator's field.
This was exceptional information. Thank you, Yaming, and thank you for joining us. And thank you all for joining our Supermicro Tech Talk. Learn more at supermicro.com/X12, powered by Intel.
Hello, everyone, and thanks for joining my talk. I'm Jerry Chen. I lead global business development for NVIDIA's manufacturing and industrial business. As you're all fully aware, we're now well into an industry transformation driven by AI. Now, it might seem like AI is inescapable in our daily life nowadays with smart devices and internet services and everything we do, but we're really only at the beginning of the age of AI. Economists call AI a general-purpose technology, but what does that mean? Simply put, a general-purpose technology isn't an innovation that serves just one singular purpose. A general-purpose technology impacts all existing industries. What are some examples of technologies that economists consider general-purpose technologies? Well, I think there are 6 big ones. Domesticated agriculture transformed us from hunter-gatherers to allow us to build the first great city-states 12,000 years ago. Written language allowed us to communicate over time and space 5,000 years ago. The internal combustion engine allowed us to exceed the power of animal labor late in the 19th century. Electricity unshackled workers and equipment from the drive shaft early in the 20th century. Information technology enabled automation in the last quarter of the 20th century. And now, AI is able to learn continuously from data, enabling superhuman capabilities. It's no coincidence that each of these general-purpose technologies were sparks that ignited revolutions. But notice that agriculture and written language took thousands of years to transform civilization. And yet in the last 100 years, civilization transformed not once, but 4 times. 4 industrial revolutions. The first industrial revolution was ignited by the internal combustion engine, a true general-purpose technology that transformed every economic activity of civilization. 50 years later, the second industrial revolution was ignited by the deployment of electricity at an industrial scale. The third industrial revolution was ignited by the broad adoption of information technology, meaning commodity computing systems. And as you all know, this third revolution, the IT revolution, has been the economic engine for Taiwan's modernization. We've now taken our first steps into the fourth industrial revolution, ignited by AI, artificial intelligence. This might be the most impactful general-purpose technology of them all, because it has the potential to learn, improve, and to operate autonomously, which means it will get exponentially more powerful over time. To put this all into perspective, our AI journey started with the Big Bang of AI, when 3 innovations came together a decade ago. Machine learning algorithms, lots of data, and GPU computing. That was the dawn of AI computing. The first production deployments of AI started with the big hyperscalers like Google, Microsoft, Baidu, and Amazon. These cloud service providers were the first to build cloud-based AI services into their platforms. And as you all know, many of these AI services consume a lot of GPUs. And these cloud investments continue to grow with no signs of slowing down. Now, the next big wave of our AI journey is represented by AI breaking out of the cloud and extending into industrial assets. This is what we mean when we say the AI of things, or AIoT. This new industrial wave has very different challenges compared to AI services deployed in managed cloud data centers. The industrial edge is represented largely by remote, unmanaged industrial assets in factories, oil fields, or rail networks. Connectivity is largely non-existent today, but emerging technologies like 5G are an enabler to deploy and to manage AI at the industrial edge. 5G is also a conduit to collect sensor data to teach edge AI systems how to continuously learn and to improve. But not all industrial edge systems have the luxury of relying on connectivity. Some mission-critical applications need intelligent agents to perceive their environments and to operate autonomously. We think of these autonomous systems as robots, but in reality, they can be complex, cyber-physical systems that continuously learn, adapt, and improve how they operate. Unlike the first wave of cloud-based AI systems, these next 2 waves of AI operate in the wild, outside of managed data centers. But this AI-infused industrial edge, or AI of things, represents enormous sectors of our global economy. What sorts of industrial applications will be affected? Well, in short, all of them. Engineers run huge HPC simulations to optimize product design and manufacturing processes. AI is becoming infused into surrogate models for design exploration and for inverse design to guide the discovery of new catalysts and industrial materials. There's wide adoption for AI for image-based quality inspection in precision manufacturing, notably for semiconductor defect detection and classification. And many of you are also deploying AI for predictive maintenance and service operations, and to support worker safety and productivity assistance. AI is also used increasingly to optimize supply chain and logistics operations. We're seeing a lot of collaborative robots and autonomous ground vehicles for material handling. And finally, all of these manufacturing and logistics operations continuously produce enormous amounts of data. Industrial applications are complex operations that require continuous and near real-time optimization. By necessity, any intelligent support system needs to fit naturally into the workflow of the human operators. The best AI systems are helping workers operate sophisticated machinery through natural language and conversational technologies. These are often coupled with augmented vision tools like AR or VR to allow seamless and natural interactions to assist workers. Simply put, every industrial sector will be transformed by AI. The potential for value creation is enormous, and the spectrum is staggering, From the most modern, highly sophisticated sectors like semiconductor, design, and manufacturing, all the way to our civilization's first great general-purpose technology in agriculture. Tremendous potential for trillions of dollars of value creation, all through AI. Let's take a quick look at a few examples.
My name is Misty. Nice to meet you.
So what are the unique challenges for deploying AI for industrial applications? Well, I'd argue there are 8 major challenges. The first of these is connectivity. Data is a critical ingredient for training AI agents. And without robust, high-bandwidth connectivity, curating that data is impossible. That's the first challenge. Now, the second is scalability. With enough data and enough talented data scientists, it's possible that all AI tasks could be architected and trained from scratch. But from a practical perspective, that's just not a scalable way for an organization to train their AI models. That's the second challenge. Now, of course, you'll need to efficiently provision infrastructure for your data scientists to develop and prototype AI models. Provisioning with maximum availability and maximum infrastructure utilization is the third great challenge. And then once you've trained your AI models, the fourth challenge is to deploy and manage those models in the field. Now, this may seem like just simple plumbing, but imagine supporting sophisticated AI in industrial equipment deployed in remote industrial environments. And in addition, all this connectivity increases security risk by exposing more cyber attack surfaces. Simply guarding the boundaries of your infrastructure is woefully insufficient. And nobody in Taiwan needs to be reminded about well-known cybersecurity intrusions that cost millions of dollars in lost productivity and remediation. Even more frightening is the prospect of lost IP due to cybersecurity intrusions. This is the fifth challenge. Now, of course, protecting your infrastructure and your IP is secondary to protecting your own people, who are your most valuable resource. This is especially true during periods of pandemic, but also true in dangerous industrial environments where safety equipment and procedures need to be monitored to keep workers safe. This is the sixth challenge. The seventh challenge is the difficulty of training autonomous AI agents that are sophisticated enough to be adaptive and resilient in messy industrial environments. And then finally, the eighth challenge is how to design and optimize factory operations in realistic, real-world physical spaces to embark on a digital transformation journey. I'm proud to say that NVIDIA is investing in solutions to address all of these challenges. Let's show you a few of them in action. High-volume manufacturing is challenging, even for mainstream consumer products. Aluminum beverage cans seem pretty low-tech, but at 60 cans per second, quality inspection is a highly challenging problem. Our partner, Data Monsters, created a solution to detect defects on the fly, inspecting 100% of every can produced and filled. This can save millions of dollars compared to the alternative, which is human inspectors looking at just a small sample of cans. At 60 cans a second, the difference between catching a problem through manual sampling 45 minutes after the problem actually happened versus catching it right away with AI could mean hundreds of thousands of defective product that needs to be thrown away. In this video, look at the images at the bottom, showing an image of the defective can next to a heat map highlighting the defect. Modern car manufacturing is highly automated for the most part. But process errors do occur, and if they're not caught right away, the car will continue through subsequent manufacturing and assembly steps, only to require expensive rework and disruption far down the line. Our partner V7 Labs has developed a platform that enables manufacturers to train inspection systems to recognize defects that are unique to each manufacturing process, and to enable their customers to retrain their AI models using their own unique data. And of course, NVIDIA uses these AI-augmented inspection technologies for our own manufacturing operations. Here you see images of our PCB assembly lines looking for surface mounting failures running on our low-power Jetson Xavier devices. There are plenty of standard AOI systems for PCB assembly inspection, but setting up a new production run is a tedious process, since every PCB assembly has unique components and configurations. Traditional inspection systems also suffer from painfully high and expensive false positive rates. Our AI system learns from every PCB assembly it sees, continuously building a catalog of components. With every new production run, our AI agent also learns more about what defects look like. It also automatically learns more and more about how to use different camera perspectives and to adapt to different lighting conditions. As I mentioned earlier, cybersecurity has become an existential threat, especially for high-tech companies with valuable IP. Yet, modern manufacturing is trending towards integration of even more complex and connected machinery. Every new manufacturing tool with computing nodes and network connectivity is a potential attack vector. What's needed is a cybersecurity solution that's embedded in the very fabric of the communication network. That's exactly the sort of cybersecurity solution that NVIDIA's Morpheus cybersecurity application framework is designed to enable, working in conjunction with our DPU network devices embedded in the network fabric.
It starts with a network. Here we see a representation of a network, where dots are servers and lines, the edges, are packets flowing between those servers. Except in this network, Morpheus is deployed. This enables AI inferencing across your entire network, including east-west traffic. The particular model being used here has been trained to identify sensitive information, AWS credentials, GitHub credentials, private keys, passwords. If observed in the packet, these would appear as red lines, and we don't see any of that. Uh-oh, what happened? An updated configuration was deployed to a critical business app on this server. This update accidentally removed encryption, and now everything that communicates with that app sends and receives sensitive credentials in the clear. This can quickly impact additional servers. This translates to continuing exposure on the network. The AI model in Morpheus is searching through every packet for any of these credentials, continually flagging when it encounters such data. And rather than using pattern matching, this is done with a deep neural network, trained to generalize and identify patterns beyond static rule sets. Notice all of the individual lines. It's easy to see how quickly a human could be overwhelmed by the vast amount of data coming in. Scrolling through the raw data gives a sense of the massive scale and complexity that is involved. With Morpheus, we immediately see the lines that represent leaked sensitive information. By hovering over one of those red lines, we show complete info about the credential, making it easy to triage and remediate. But what happens when this remediation is necessary? Morpheus enables cyber applications to integrate and collect information for automated incident management and action prioritization. Originating servers, destination servers, actual exposed credentials, and even the raw data is available. This speeds recovery and informs which keys were compromised and need to be rotated. With Morpheus, the chaos becomes manageable.
Now let's take a look at SimNet, a framework for running physics-informed neural networks on GPUs. Here it's used to solve partial differential equations, to simulate a coupled fluid flow and heat transport problem, to optimize the design of a heat sink on a motherboard. The training takes 4 days on a single DGX system, and once the AI model is trained, we can evaluate and explore 25,000 different configurations in a matter of seconds. This is a groundbreaking example of how AI can be infused with the understanding of coupled physics so that it can be used as a surrogate model to explore the design space to find the optimal configuration. We use tools like this internally at NVIDIA to do design space optimization for our own products. Here's a demonstration of something I'm really excited about. BMW Group's Smart Transport Robot and SortBot uses NVIDIA's Isaac platform to train the robots in a simulated environment for motion planning, object detection, and pose estimation. The robots are training in a virtual environment using Isaac Sim running on Omniverse to provide a simulated training environment with physical rules and realistic visuals. This approach, called Sim to Real, is designed to train an autonomous AI agent to safely learn in a synthetic environment. Then the trained AI agent is taken out of the virtual simulation and inserted into a physical robot in the real world. That real-world environment is practically indistinguishable from the synthetic world where the AI agent was trained. The results are remarkable. This approach promises to transform how industry trains and deploys robots in all sorts of industrial environments. Now, I've said that these advanced robots all need to be trained in a synthetic environment, but modeling a real, complex, modern manufacturing plant to the level of detail necessary is a daunting task. Furthermore, even a physically accurate model would need to look almost identical to how the robot would see the world, with its entire array of different sensors. But that's exactly what the BMW Group achieved, working with NVIDIA using NVIDIA's Omniverse platform.
Can you tell how far I have to bend down there?
So we'll get you a taller one, but there's...
Yeah, it's perfect.
BMW used Omniverse to integrate a range of planning data and applications to allow real-time collaboration with open compatibility. This achievement represents a huge leap forward in the field of digital virtual planning. BMW and NVIDIA envision a future where a virtual representation of an entire manufacturing production network enables an integrated approach to planning complex manufacturing processes. Omniverse greatly enhances the precision, speed, and efficiency of this planning process. We look forward to the time when production planners at BMW Group will be able to visualize the entire planning lifecycle for every plant in their global production network, accelerated by scalable GPU infrastructure. Omniverse will also help enable a wide range of AI-capable use cases, from autonomous robots to predictive maintenance and data analysis, a true digital twin of a factory. Now, I've just shown you many fantastic AI-powered technologies. All of them show our commitment to creating new markets, but none of it would be available unless our technologies are easily available in the market. That's why NVIDIA's business model requires relentlessly broad ecosystem support. We're available on every major computer platform, in the cloud, in data centers, and on edge devices. We support Power, ARM, and of course, x86, Intel, and AMD platforms. Our business model also requires relentless ecosystem building, investing resources with all of our partners, so we can lift all boats by enabling and accelerating all of our ecosystem partners. I want to thank each and every one of you for your support and for your commitment to joining us on our journey into the age of AI. We can't wait to transform the future of the industrial edge, the industrial AI of things, with all of you. And I can't wait to see what we can build together. Thank you.